Hello and welcome to part 2 of my course on pre-probability and pre-analysis topics. In this course are going to talk about algebraic structures or mathematical structures such as groups, rings, and fields. From very basic elementary concepts such as sets, which are just collections of items, we build functions and operations in part 1, and in this course we'll look at special elements of sets like identity and inverse and idempotent elements. And then these, along with properties of operations, will allow us to define structures like groups, fields, and rings. So in this course we neatly combine everything that was covered in part 1 as well as the new material covered here and turn that into a final product, and that's the algebraic structure. And with that we will have built the rules of algebra, calculus for that matter, from nothing more than sets, special elements of sets, and some rules to combine those elements. Now, algebraic structures will give us a list of axioms associated with those structures. There's a list of axioms, and we learned about axioms in part 1, associated, for example, with a ring or a field. And you may wonder, what use are those? Why do we care? If a structure is a field or a Boolean ring, how does that help us? So it turns out these structures, these axioms, allow us to prove the simple, basic rules of algebra that we've learned before but just taken for granted that they were correct. We can now actually prove them. And we will, at the end of this course in the review session, prove an example from Walter Rudin's Principles of Mathematical Analysis, 1.15c here. That if x it does not equal 0 and the product xy equals 1, that implies that y is the inverse element of x. And we'll do this proof with the axioms identities coming from a field. So that will be covered in this course. So let's quickly look at what's covered in this course, in this part of the course. There are 10 sessions followed by a review session. In those 10 sessions we'll cover Boolean addition and multiplication, identity and inverse elements of sets, including additive and multiplicative inverses, idempotence, Boolean polynomials, sets of sets like the power set, and basic set operations on elements of sets. And then we'll see that we can look at that as set addition and multiplication. We'll look at set negation and difference, and then combine everything into algebraic structures, groups, rings, and fields, and other algebraic structures. And we end up finally talking about Boolean rings, which is one particular type of algebraic structure. And we'll see that set algebra is an example of a Boolean ring. I hope you'll join me for this short course on algebraic structures.